Please start with a very brief but also an essential question. So, sir, perhaps you can tell us in brief about the parts of the entire InspireSat missions that were carried out in and by IIST.
Okay, so the question you are asking is what are the various parts that IIST is developing in this mission?
Exactly.
So in addition to the parts, I would begin like this, that the conceptualization of this mission, from the time when we started conceptualizing this mission, we were involved in this along with University of Colorado, and then there was National Central University, Taiwan. So NTU Singapore joined in at the latter phase of time, where they helped us with developing the codes on the onboard computer. So the main if you look at the hardware wise where we have contributed, it would be the onboard computer. The basic design happened at IIST.
Yeah.
We made around 3 prototypes before the final prototype, which was manufactured by or basic at Laboratory of Atmospheric and Space Physics. The final hardware was made there. However, we had 3 prototypes which we had developed at IIST and which were used during the initial phases. Then we had the electrical power system, which is basically a DC-DC converter, which is taking the power from the solar panels and charging the batteries.
Exactly. Yeah.
So even this was designed at IIST and then finally fabricated at LASP and NCU, Taiwan. So the final flight hardware I meant, because by that time during the final phases, the students were at working in those Laboratory of Atmospheric and Space Physics, where the hardware, final hardware, they had developed in the sense, made the fabrication. So these are the 2 key things. In addition to the ground station support which we are providing, so ground station was completely built at IIST for supporting this mission, because the agreement what we had in the beginning was that IIST will own the satellite. So the satellite is finally, the ownership of the satellite is transferred to IIST, or it's an Indian satellite now. So yes, these are the hardware wise, 2 hardwares in the flight and the complete ground station support. The ground station, which is in the 2 bands, UHF and S band. Yes.
Yes, sir. So, like, what would you say were the challenges when you were trying to make the size of the satellite smaller when it comes to the communication, and like how did the antenna sizes affect from a bigger satellite, or how were your how did you design work on it?
Okay, the challenges you are indicating is about the miniaturization. So in a bigger satellite, we always begin with the philosophy that the spacecraft is going to exist there for a very long period of time, so 15 years or something. So historically and by legacy, there has been a trend to using components which can withstand the radiation, so or which are space qualified, we say. By space qualified, we mean that it is able to withstand the temperature ranges as well as the radiation that it can encounter there. So that would mean that we cannot use silicon wafers below certain dimensions, because they will be prone to something called as the single event upset. However, in the case, the philosophy of a smaller satellite, especially the university satellite, begins with the state philosophy that the COTS industrial grade components which are available in the market nowadays have improved their quality to such a level that for a shorter life of the spacecraft, we can use these components. Shorter life in the sense that by reducing the redundancy. So in the case of bigger satellites, since the investment goes into hundreds of crores of rupees, the requirement there is it should be redundant, and it should we should make sure that it will never fail.
Yeah.
So we relax that redundancy requirement in the smaller satellite, and also use the latest technologies which are available as industrial grades for making the satellites. But these are not used in the traditional big satellite design. So latest technologies are used, but for common subsystems, they go with the legacy hardware which were available probably 20 years ago or something. Even though many new developments are happening in the modern for modernization, so this has been the basic trend. So the miniaturization challenge is mainly the components are very small, and at an university level, handling these things are difficult. So we look at industries which can help us in making this complete system. Basically, we go up to the layout design, which means that we draw the schematics of the circuit, make the layouts of the PCB, and then outsource it to the industries to develop the rest of the subsystem. So this is possible now because of the huge improvement in the industrial grade components. That is why miniaturization is possible at this particular moment of time.
Also, sir, at this point, can you also talk about the S-Space facility that was incubated in IIST for the sole purpose of small satellite missions, and the ground station facility, which takes care of the entire processing of the InspireSat data processing? Yeah.
So the formal inauguration of the Small Spacecraft Systems and Payload Center, which we call it as S-Space for short, was in 2018. So we did not have multiple laboratories at that point of time. Right now we have 3 laboratories, one for developing the sensor, which is handled by Dr. Umesh. Then we have 2 more laboratories, the ground station laboratory as well as the electronics fabrication laboratory at IIST. So these 3 laboratories, what we have. Then the ground station was built from scratch with a different philosophy. Instead of buying out full-fledged things like there is something called modems like Cantronics and other things. We started looking at SDR-based ground station, which is actually the latest in the communication area. If you look at any traditional communication system, they are actually fixed to certain kinds of modulations and the frequency levels they can operate on.
Right.
However, our ground station is extremely flexible, of course, except for the RF front end, which has to be changed. The digital systems need not be changed at all. So we built this flexible ground station. There were it took a long time for us, but I think once we started working with the once we started commissioning the InspireSat 1, we were rapidly able to progress to right now have an operational ground station.
Nice.
In the case of the electronic fabrication laboratory, we brought lots of soldering equipment, which is basically required. Then we have a small clean chamber, what we call it as laminar airflow chamber, for assembling the spacecraft and keeping the final spacecraft inside. Then we have the standard temperature chamber where you can bake the PCBs before you send it out for the assembly. Then we have all other things are basically equipments like CROs and power supplies to handle the functionality of various subsystems.
Right.
Of course, we are not complete yet. We need lots of more facilities which need to be augmented to allow us to improve the speed at which we can develop the subsystems and the satellite.